In a previous chapter, we talked about how we can prove that triangles are congruent. So if you remember, there were some shortcuts that we used. Side, 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 angle, side, angle, angle, side, and hypotenuse leg. Now, when working with similar triangles, we can also show that triangles are similar using certain shortcuts. The only thing is, instead of trying to show that certain sides are equal, we're going to show that certain sides are in proportion. So just like when we prove triangles congruent, there are shortcuts for proving triangles similar. We don't always need to go through all of the steps. Now, all of the steps would mean make sure that all angles are congruent and make sure that all sides are in proportion. Now, if you're trying to prove that two triangles are similar and you want to use a shortcut, there are 3 of them. The first one is angle, angle. Second one, side, side, side. And the third one, side, angle, side. So let's start with angle, angle. So this says if 2 angles of one triangle are congruent to 2 angles of another triangle, then the 2 triangles are similar. So here's an example. We have triangle ABC and triangle DEF. And in this case, we know that angle A is congruent to angle D, and then angle B is congruent to angle E. If we know those 2 pieces of information, we can say that triangle ABC is similar to triangle DEF. Now let's go ahead and apply this. So here it says, determine whether the triangles are similar. If they are, write a similarity statement. Explain your reasoning. So in this case, we see we have angle D and angle G are right angles. And if we were to apply the angle sum theorem, we know that all the angles in a triangle sum to 180. So we find that the measure of angle E is going to equal 64. Now, since angle E is equal to 64 and we see angle H here equal to 64, we can use the angle-angle similarity postulate. Just like how you use the shortcuts to show that 2 triangles are congruent, we will also write this out the same way. So, starting with the angle, we have angle D equal to angle G. And then we have the other set of angles, angle E is equal to angle H. And so by the angle-angle similarity postulate, we can say that these 2 triangles are similar to each other. All right, the next shortcut is side, side, side. So if the corresponding side lengths of 2 triangles are proportional, then the triangles are similar. But this means you have to show that all 3 sides are in proportion to each other. So if AB over DE is equal to BC over EF, which is equal to AC over DF, then you can say that triangle ABC is similar to triangle DEF. Now you're not given any information about the sides, but you don't need them. Once you know that all 3 of the sides are in the same proportion to all 3 of the sides in the other triangle, you can state that those 2 triangles are similar to each other. That's the shortcut. Go ahead and look at example 2. Find the value of x that makes triangle ABC similar to triangle DEF. Now, since we know that triangle ABC is similar to triangle DEF, we know which parts correspond to each other. So, AB goes with DE, BC with EF, and AC with DF, and they're all in the proportion of 1 to 3. Now I know this because AB over DE is 4 over 12, which is equal to 1 over 3. If that's the case, we can use that ratio to set up our proportions. So BC over EF is equal to 1 over 3. And then we can substitute, so BC is x minus 1, EF is 18. Cross multiplying, we have 3 times x minus 1 equals 18 times 1. So 3x minus 3 equals 18, and 3x equals 21, so x is equal to 7. Now if you wanted to, you could set this up instead of using BC and EF, you could have used AC and DF and get the same answer. We have one more shortcut to go over. That's side angle side. If the lengths of two corresponding pairs of sides are proportional and their included angle is congruent, then the triangles are similar. So in this picture here, we have angle A congruent to angle D. And you also know that AB over DE is equal to AC over DF. Then you know that triangle ABC is similar to triangle DEF. Now, just like with congruent triangles, when we say side angle side, the angle refers to the included angle. Take a look at example 3. Tell what method you would use to show that the triangles are similar. Let's look and see what information we have. Do we have angles given? Do we have sides given? Well, even though we don't have angles given to us in terms of their actual measurements, we do have a set of vertical angles, and remember that vertical angles are always congruent. Now, what about the sides that are given to us? Are they in proportion? Let's check. 9 over 15 is equal to 3 over 5, and 18 over 30 is also equal to 3 over 5. Since we have the vertical angles congruent to each other and two sets of sides that are in proportion with one another, that means that we can use side angle side, as the vertical angles that are given here are the included angles. So to write this out, we would say, tell what method you would use to show the triangles are similar. That would be side angle side, but we want to go ahead and write this out. So the first set of sides, AC, is similar to CD. Angle ACB is congruent to angle ECD, and side BC is similar to CE. So we can say that triangle ACB is similar to triangle DCE. So as a summary, we can prove that two triangles are similar by 3 shortcuts. First is angle-angle similarity. So two angles of one triangle congruent to two angles of the other triangle. We have the side-side-side similarity theorem. That's corresponding sides of one triangle in proportion to corresponding sides of the other triangle. And then lastly, we have side angle side, which is two sides of one triangle are in proportion with two sides of the other triangle, and the included angle of one triangle is congruent to the included angle of the other triangle.